Okay, so given is, so perhaps I will wait for another 1 minute. Supposedly we need to start, right? That's why I really hope all the students can join on time. Perhaps you can remind your classmates. Okay, because I don't want any one of you miss any important information. Okay. Okay, good. So perhaps I will start now. So any question you want to ask before I start the class? Again.
No question, sir. I think you can proceed.
Okay, so no question. Everything is so clear. Okay, good. If no questions, we just continue. Because as I said, I won't burden you too much for each of the sessions. Perhaps I will just share again about your just give me a second. Learning plans. So today we are going to, today is 29, am I right? Yes, we should able to finish chapter 4 by today class. Okay, so on your Thursday, on your Friday class, hopefully I've marked all the paper and I'm going through your assignments and also test 1 questions. So in the meantime, please go and redo your sessions, redo your questions. Make sure you know how to solve it. So next week onwards, I will start the chapter 5. In fact, chapter 5, I need only 3 class. Okay, you should be able to do the dimensional analysis. And before I forget, perhaps I will share you the notes over here as well. Because for chapter 5, I didn't use any presentation slide because I think the presentation slide is quite complicated, which I don't think it can achieve what I want. So I'm going to share you only the notes, because by using these notes, it should be good enough to tell you what you need for all these things. Okay, so next chapter will be the Buckingham Pi theorem, how you are going to look for the dimensionless equations. And I'm going to teach you these methods step by step. And I would say that this is not a difficult chapter. Okay, not a difficult chapter. So I'm going to share you now before I forget. The 5 non-dimensional indices. Okay, so if you got time, you can refer that first. Okay, and of course, I'm going to brief you and explain in details from time to time. Okay, so it's there. Okay, so just for information, chapter 5 have no slide. I'm going to use only the notes for that. Okay, so don't worry if you see in CN there's no slide it's posted over there, because I don't think the slide, as I mentioned, the slide is not clear. It's quite complicated for you to understand. Okay, so that's the thing. So just get back to chapter 4 again. Just give me a second. Where's my pen? Oops. My pen is not connected. Just give me a second, right? I need to connect my pen. And by the way, did you all took your vaccinations? Or have you registered? Or
Not registered yet for vaccine.
I see. How about for those Malaysians? How many chapters do we have in our syllabus? In our syllabus, we are going to have 6 chapters. So I think I shared this already, right? Under your CO. And you will have a CRO1 up to CRO5, where CRO1 is chapter 1 and 2, CRO2 is chapter 3, CRO3 is chapter 4, CRO5 chapter 5, and CRO5 is chapter 6. And what the work plans I shared just now, chapter 7 and 8 is something extra. I want you to know some knowledge, even though I'm not going to examine your understanding on this, but it's good. Perhaps I only use 1 week's time to introduce to you all this information. Okay, because I realize this is something you must know before you go, else you will lack things of some information if you after your fluid mechanics. Okay, so that's the thing. No, so as I mentioned, your final chapters, final exams is only chapter until chapter 6. In fact, in week 12, all your syllabus should be covered, fully covered by everything, even though your final is only until chapter 6. But again, for me, knowledge is not about only finals. I'm not sure about you, but anyway, I'm going to share all these things to you. I just hope that you learn something new and learn something important, what in my experience tell me. Okay, that's why I know that's not going to include in the final. Some student might think that, oh, that's no longer important, I can skip that. But for me, personally advice, don't think in that way, because knowledge is something priceless. You learn all the things not for final only, am I right? So all these things, believe me, you will appreciate what you learn today when you come to the final years or third year of a level. Because all these things, as I said, especially fluid mechanics, you can't leave that. Anyway, yep, but I hopefully for all the 6 chapter you are do well. But again, right, don't have the kind of habits. Just my personal advice. I'm not to say it's not good of a level. Don't do it because of examinations, and then you lost the interest for learning. What is the point? I mean, it's like you do it only for final, but you not really develops your knowledge. This is something I'm not encouraged, to be honest, right? Because for me, I'm not told. Yep, for me, I'm not. Maybe chapter 7 is so easy. So, are you sure? Perhaps you are lucky for this semester, to be honest, because I have not enough time to include in the syllabus yet. But perhaps for next semester, they are going to be included. Okay, yeah, that's the thing, because we increase from time to time to make sure. Again, I want all the students to learn enough knowledge from the fluid mechanics before they leave it. Else, just like you said, right, not tested, so you're not interested, they shouldn't be aware for me anyway. Okay, but anyway, chapter 1 to chapter 6, and don't think that is easy, as long as, unless you are truly understood the knowledge. Else, I would say that's something you need to know how to do it. Okay, and there's another question. SUS, what is that? I didn't get what you mean. But anyway, so the test 1, as I said, I tried to return by Friday, this Friday, if I can, because I'm still marking and we got quite a huge number of that. If I can't release by this week, next Tuesday or Monday is the latest. Okay, I will let you know definitely. I will let you know. Okay, so any other questions? Seems like you're all very happy if there's no chapter 7, 8. But anyway, okay, so let's start with this. Chapter 4b. So again, as I said, first thing, you must know what is V omega. V equal to R omega. I hope you have recapped this, where I'm not going to tell you again. Okay, V equal to R omega. Why I say all this information is so important? as I briefed you just now, as I briefed you in the last class, in the angular momentums, you will have a summation equal to, can someone let me know where's the summation for this? Summation of moment equal to summation of
R M dot B out minus
okay.
summation R M dot B.
Okay, so this is the thing you must know under your angular momentums, right? Summation of the out RMV minus summation of the RMV in. So the key information here, why you need to know V equal to R omega? Because under your angular momentum questions, not all the times, all these will be given. It won't straightforward to give you, I got my velocity is this, I got my mass flow is this. I think you experience a lot. When we want to know the mass flow rate, a lot of times it can link to the volume flow rate, and even those your velocity and area. So the question's tricky parts would be, not all the times the question give you straightforward. If you give you velocity or area and do backwards to get the value of mass flow rate, and then you can put in or you can fit in accordingly. Same to your velocity. Not all the times the question will directly give you the velocity for that. It will just give you R omega, or let you know the omega for this case is what value. So you need to know how to link back to velocity. And in terms of your omega can be in a lot of different terms as well. Am I right? As what you learn in the chapter 1 or chapter 2. If the question not given you omega, question given you the RPM or whatever, you need to know what kind of formulas can bring you to the velocity. The question might be only just give you the rotational per minute or rotational per second of a level. You should able to link up all these information to get your velocity. Once you get your velocity, you should able to link up to these final formations. So this is about the tricky parts, especially for this chapter. Okay, so what I would like to highlight over here. So as I said, this is derivations, how the summations become RMV. And I don't expect you to know that. Just in case you forget it's RMV, you can derive from the I omega. Because you know that, as I mentioned last class, you know that my momentums for angular momentum is equal to I omega. And for the linear momentum is mv, right? So in fact, you can start from here. I omega also equal to R squared M omega. And once you eventually to modify it, at the end, your angular momentums also can be written in form of RMV. This is a mass flow rate, okay? M dots. Okay, so this information you need to know. Is that clear until here? Okay, if no questions, I will carry on. And again, please stop me if you're not clear in any parts. Okay, yep, for the test 2, yes, it's confirmed. If I didn't make any announcement, that's a date we are going to fix. But anyway, around that time, I'm going to give you announcement again if there's any changes. So once you know this is a key point you need to know. The next thing you need to know is the work done. So you know that you learn in the chapter 3, right? All the linear work done. Let me think of that. But anyway, so I just let you know that in the angular momentums, you got what? You got the omega times your moments is your work done. Okay, what means by work done? That means all this of rotational times your moment force is your energy generations. So this is one of the very important formulas you need to know. And the tricky part is You know that omega can be 2 pi n of level. So this one has been briefed just now. But the m is reference to the moments, right? The angular angular momentum of level, right? But this one also can be referred to your dots, angular of dots. Okay, because when you got any perpendicular force apply tangentially on this surface, these dots times your r is your moment, am I right? So this is one of the very important formula you need to know. What is the power generation from these rotational conditions? Okay. So any question? No. Okay. So this one is fine. So as I said, shaft power is important. Make sure you know it's this, and this m can be also in the dots. Okay. And of course, the rotational energy, you already know that, because you know that the half mv squared is your kinetics, linear kinetics energy. Okay, and yep, that's all. This one is so important. But for these ones, you just need to aware, but I don't see very much questions you ask in this way. Okay, r omega squared is your acceleration, but I don't see a lot of questions you asking it. But anyway, this one is something you have been learned in your static in the past, am I right? Just need to recall this. Okay, so once you get all these informations, now the time for the calculations. And again, as I mentioned, I didn't expect you to derive this. You can try your own if you want, but I would say that I don't expect you to memorize. Not to memorize. I don't expect you to know exactly this derivation. But what I wish you to remember and wish you to understand is this one, as I mentioned. Summation of m equal to summation of rmv minus out in rmv. So once you get that, you can solve all the questions, to be honest. Okay, so with that, this done. And today I would like to highlight over here your radii flow device. So your radii flow device is something very special, as I mentioned in the last class. Is you using all the shaft energy, turns all the turbines to generate not only linear momentums, but only angular momentums. So this is a special case for radii flow. So how the question is going to ask you? So I would say that when the question asks you what is the angulars in and out, etc., this is the thing you need to know. Okay, of course, when you look at this area, this is the discharge line from the internal rotations to the outer linear. So that's why there's a combination, just like this, okay? The rotational, all the angular momentums happening right here. But at the end, you are going to have a linear momentums happening on the discharge line. So you need to know that because they are in the same system, that's why they are going to have a conservation of mass. Okay, when you know that there's a conservation of mass, you know that all the volume flow rates inside the system, no matter it's from the angular ones or goes to your linear ones, it remains the same. That's why you got the V1's mass volume flow rate equal to V2 volume flow rate and equals to the overall volume flow rate. Can you understand me until here? You can understand me, right, class? Yep. Okay, if no question, I just carry on. So from there, you know that, I mean, forget about this first, right? Forget about this. You know that my volume flow rate always equal to velocity times my area. Am I right? So the question would be, of course, the velocity is velocity. It's velocity of 1 and velocity of 2. But what kind of cross-sectional area you need to consider over here? Why is 2 pi r b1? Anyone have gone through this? Can you share me your thoughts? I is 2 pi r1 b1 in this case. Anyone have gone through this? No one? Haven't gone through. No worries. Okay. So I leave it to you. I want you to find this out. Why 2 pi r1 b1 in this kind of case? And I will going to ask you in the next class. Okay, go and find out why this happening, and I want you to remember truly what's going on over here. Okay, once you get all these things, because in this case, as I said, they are not going to give you a straightforward velocity. That's why once you get your velocity, you can easily to fit in to this RMV to find your angular momentums, right? And after that, okay, and after that, once you get your angular momentums, this is the difficult part, to be honest, for the angular momentum. After you get your angular momentums, in this case, in fact, all the energy is drive to the shaft, right? If you look at the side view from here, all these things turn in, you got the shaft attached to that. Okay, so once you got this shaft, this formula come in, the Euler's turbine formulas. But don't get worried on that. It's the same concept because they are going to use your mass flow rates of the R2V2 minus your R1V1. And of course, the angle is very important. Depends on what kind of energy directions you are referring to. Okay, and I'm going to go through some example later, so don't worry on that. So get the concept ready. So, and again, this V2, this V1, not all the times they will give you the velocity. Again, you need to know this R omega. And we've got R omega, you've got the R, 2 pi, and etc. All these things you must able to link up. So at the end, what the question interests most of the time is your shaft power. How many energy, in fact, you need to input, or how many energy is driven distance. So you will have your omega T shaft, as I mentioned just now, just like your omega M. It's the same thing. So from there, you should be able to know what is your energy generations for the shaft. Is that clear? Two pi r, yep. Cylinder area, yes. Yep, just figure out and try, yep. This one, of course, you know is the area, cross-section area. I just wish to know why is 2 pi r b1. Go and figure out, and I'll let you know the answer next class. This is cross-section area, this, right? Because you know that is already, oops, where's my cursor? Yep. You already know that is VA, am I right? Of course, this is referring to your cross-section area. But why this is not pi r squared? Or why this is not 2 pi over level? I leave it to you to get me the answer for this. Okay? So once you get all these things, you are done for the chapter 4, to be honest, right? If you are really familiar with all these formulas, exchange here and there, etc., and you should be able to score these subjects. I mean, to score these specific questions. So now I want you all to try on these questions. I believe perhaps not every one of you has been trying. So please spare 5 minutes time to try on this, please. And I'm going to go through 2 pi r is the circumference. Yep, just check it, right? You're almost there. Okay, I would say you all are almost there. Just check it. So for these questions, the question is oops, what is this? Underground water, right? The underground water is pumped through the 10 cm diameter pipes that consists of 2 mm long, not 2 mm, 2 meter long and 1 meters horizontal. And you can see that all your discharge is discharged at 3 meter per second. And you know that the mass of the horizontal pipe section when filled with the water is 12 kg per meter. Okay, just be careful on this. 12 kg per meter length. What does it mean? So the question asks you to look for the anchoring forces for all these things. As I mentioned last class, this thing can be in linear as well. But the questions highlighted that they want the bending moment on the point A. Okay, so try to solve this. And I've given you 5 minutes, 5:35. I'm coming back for this. Okay, any question you want to ask? And of course, try not to refer to the answer. I know all the slides ready, but I want you to have some critical thinking to analyze and understand what is happening right here. So you will learn something new. Okay? So I leave it to you. 5:35, I'm coming back to discuss for this question. Okay? Any question?
No.
No, yeah, just have a try. Just have a try. Okay? So just to add on for that, right? First things you need to know the formulas, right? And again, as I said, for this case, all the times you're using these formulas. So in this case, the special thing is you don't have any inlets, am I right? But what the inlet contribution, as I mentioned, last linear things. In this case, you need to consider your weights, W, weight W. So this one eventually will go into this. And please be careful on all the directions, okay? Because I think you all learn well on the statics. When talk about moments, there's always the directions play an important role. Am I right? Because you need to know which directions. So don't worry if you get a different answers. But I will just highlighted that you must know what directions you are referring to. For example, you're referring to clockwise is a positive, or you're referring to anti-clockwise is a positive. It doesn't matter, okay? As long as you define clearly, then should be fine. Okay, that's the thing. So in this case, I would say that the challenge parts you have is only you need to find the mass flow rate, am I right? Because seems like you don't have the mass flow rate value. You got only the velocity value. Am I right? So after this, and you should be able to get answers. It's not difficult. Okay, but this one, the difficult part would be, what is W? Where is the weight? Can someone tell me? What is the formula for the weights?
G.
Yup, mg. So from here, you can use the mg, but bear in mind that your mass is kg per meters. So in this case, you need to make sure that you are referring to this meter as well. So you can use the kg per meter times this total length of a water lake, this water weights, and that contributes to your rotational. Okay, so have a try, have a try. So can I know how many of you able to get answers?
Not yet, sir.
Not yet. Yeah, anyway, just try. I really hope you take this time. I know a lot of you not trying at the home, and please make use of these times to try. Okay. I'm going to go through the answer with you together, so don't worry. Okay, I'm going to go through. So for today's class, we are going to go through 2 questions, and I'm going to show you some examples in the textbooks. And that's all we need to learn for this chapter. Okay, it's not difficult, I would say. Okay. So is that okay? I go through the answers with you, or you still want to try on that?
So you can go through.
Okay, so for others, is that okay? May I know how many of you stuck at which part? Can I just know generally which parts you stuck? Can I get some feedback, please, so I know where to highlight? Or you don't know how to start events for the whole thing?
The WA, what does it mean?
Oh, WA. Okay, it's fine. Okay, so let's go through that. Okay, so now let's start. You can see my screen as well, right? Okay. So as I mentioned just now, because you know this is the formula you must use, regardless of all the things. So make sure you know this is the thing you need to know. So in order to achieve this, okay, in order to achieve this, you know I don't have the mass flow rates. Am I right? And this case is the conservations of mass because all the things in the same system and same diameters. That's the key things. That's why you should expect there would be a M1 equal to M2 equal to overall M. That's why you can use the rho AC times of V to get your mass flow rates. For this, you have no problem, right? And you shouldn't have problem for this, to be honest. So you will have a yep, of course, y is pi d squared over 4. I'm not going to limit you. Either use a pi d squared over 4 or pi r squared. Up to you, I don't really mind. But the key thing, make sure everything in the meters. Okay? And once you have that, you know that my water is going to be a 1000, and I got the cross-section area, and I got the velocity. You can easily to know that the mass flow rate for this case, this is the value. So it's all right, for this case?
Yes.
Okay, so after that, you know that W equal to mg, right? But in this case, it's given you, let me go back to the questions. The horizontal pipes, the mass of the horizontal pipe section when filled with water is 12 kg per meter length. That means if this section is 1 meters, I will have 12 kg. If this section is 2 meters, I will need to times become 24 kg. Do you get what I mean? So this is the tricky part for these sessions. So the questions tell you that my horizontal weight is 12 kg per meter length. So that means I got 1 meter over here. I know that my W equal to mg, where I already got 1 meter's length. That's why you have 117.7 newtons in this case. Are you okay for this? No question, right? So
Yes.
No question, sir.
okay, good. So now come to the momentum part. As I mentioned, summation of m. Oops. Where's my cursor? Summation of m equal to summation out RMV. Don't forget about the mass flow rates minus RMV in RMV, right? So you know that in this case, very obviously, there's only one outlet, right? And there's no inlets because you don't know where's the IMV1, right? Because there's not inlet from here. So when you do this case, but you're going to consider your weights, where this contributes. And if you can recall in our linear momentums, when they're going to consider your weights, always they consider as your inlets. Am I right? So in this case, you have the moment of A, because the question given you, right? Bear in mind, the direction is over here. Moments of A, so I write something like this, moment of A equal to, I need to copy this and I'll show you. Okay, so moment of A, this direction, right, equal to, you know that is your RMV out over this, MV2 times your R2, right? So write down this R2 MV2. But bear in mind, because this is your positive directions, but when you have your RMV2, you go into this one times your length is going to these directions. That's why I need to put a negative. Can you follow me?
Yes.
Okay.
Yes.
And you know that the formula is minus. Put a bracket. My RMV1, I don't have anything, no value to input, right? But I got the contributions of the weights in where your weight is also negative directions, because you already assume this MA is positive directions. So you have a negative R1W. R1 times your W. So you have a rotational moment near the point A. Okay? So once you reach here, oops, I just minimize this first. You will have your MA equal to negative R2 MV2 plus R1W. Okay, this W is the weight. Okay, I write it better. It's not omega. Okay, so once you reach that, this will answer you. This is a final format. It's okay.
Yes, sir.
Yeah.
So
So-
for the for the R1 weight, why have to put negative?
Because of the formulas. Okay, just start from here. You don't let this formula confuse first, okay? I know that's my summation of RMV. I write it down first, but because I already assume these directions rotational is my positive, so this one will become my negative because it rotates another directions. Okay, and the formula is minus, so I put a minus, and then I put a brackets only to consider what is my input energy or input forces or input moment. Then from here, my weight is happening here, and I got the R1 radius, and the rotational, the angular momentum happening also turning negative positions. So I need to put negative for my inputs. So after you solve the mathematics for this is the final parts you get. And this is what the main reasons you get this for the momentum. And I would say this is the tricky part for all the questions in chapter 4, part B, because you need to analyze and understand how these directions contribute to your system. This is just a guideline, general guideline to tell you these formulas. So bear in mind and be careful because this is negative. And I would say this is a very common mistake happening in most of the year. Can you understand me until here?
Yes, you can.
Okay.
No, sir. Could you please repeat?
Repeat. Yeah, sure. So yeah, just let me know if you can't understand. This is good. Okay. So
Yeah.
this part you okay, right? Mass flow rates, weights, you
Yeah.
okay. Okay. When it comes to the momentums formulas, summation of m equal to summation of out minus summation of in, where I mentioned this theory is same theory as in your linear momentums. This is not going to change. Oops. Can I just mute your mic, please? Sorry. Yep. Okay, thank you. So once you get that, you understand this formula, right? Until here, is that okay? This formula first.
Yes, sir.
Yep. So for others, you're okay for this, right? Okay.
Yes, sir.
Good. So in that case, now we start from here. I know that my summation of m, that means in this question, specifically these questions, they're looking for the moments at the point A. And from this diagram, I know that my moment A in the anti-clockwise directions is my positive because of the diagram. Of course, if you want to consider another anti-clockwise, that's another story. You just need to remove all these things. So I will write my MA in these directions is a positive. Okay? Equal to my output of my forces. In where? You can see from here, mv2 times my r2. It will generate these rotations of my moments. You can get me right? Okay, so you know that I know the energy generated is R2 mv2. I have no issue on that. But in this specific case, I know my output generation will be a negative because it's against the directions of my initial moments. So I put a negative R2 mv2. This is done for my first part. Is that clear until here?
Why it's minus?
Why is minus? Because it's okay. Perhaps I need to write down another. I get another words to write. So just a recap in your statics. If this is my point A, the force moving to this is a positive. Okay, if this is rotational force or your angular force in this anti-clockwise direction is positive. Any force against these directions, it will be negative. Does that make sense? Can you recall this, right? Recall this. If any force in this clockwise, anti-clockwise direction, it will be positive. So any of the clockwise directions will be negative. So please recall this. This is a very important under the these sessions. So why this is negative? Because you can see from here, if I copy again. Okay, this is my assumption already from the moment of A. I'm assume this way is rotate this way is a positive. But because of the mv2 is over here, and your distance is r2, because we focus on the point A due to the requirements of the questions. So you know that if this horizontal force times my r2, I'm going to generate a clockwise moment according to point A. So this will have a negative value. Is that clear? Can you understand me, class? Yeah.
Yeah.
And if you don't really understand this, I will suggest you to recall the statics, because I believe, especially in the statics for the moment, too many mistakes happening due to you didn't understand all these rotational positive and negative. And you need to make it clear so you can easily apply over here. Okay, so come back to your questions. So once you make it done for the summation of outs for the forces, bear in mind your formula is minus. So you minus, put a brackets, get what is your input force. Okay, so in this specific case, you don't have any flow inlets, right? Because you don't have any flow for this condition. You got only discharge. So you are going to consider only the weights, because this not going to contribute you any of the rotations. Am I right? Your MV1s not going to contribute you for any rotations because it's acting on the point A. So we are not going to consider this. Do you get what I mean? Point A. I got only the Fy. And how we are going to contribute for the rotational? We are not going to contribute for any rotational force. That's why this MV1 is not considered. Is that better if I explain this way? Yep. Okay. So if no question, I carry on. So, but what you have is only the weights. If you remember our last sessions on the linear momentums, I mentioned that if the question asks you to include the moments, the weights, you need to put that in the inlets as well. Am I right? So you got the W over here, and this W going to contribute of this distance. W times your R going to contribute a moment in the point A. And why is negative? Because again, it's happening against the clockwise. This is anti-clockwise positive, and clockwise will be negative. So once you understand this, oops, where's my cursor? Yeah. Once you understand this, you just need to solve mathematically and you will reach this formula. And I would say that this is a very important process where you need to know how to analyze the diagrams and how to analyze the forces in this kind of conditions. And what fluid dynamics teach you is only these formulas, out minus in. But how these forces come through, in fact, is from the statics. Is that clear? Any questions? Can you follow me? Okay?
Clear, sir.
Yep, thank you. So once you reach these formulas, and then it's just a substitutions. Substitute the value accordingly, and you get the value of the moments of negative 82.5. So what does means by this negative? So as I said, in moments, don't get surprised. If negative means this assumption is wrong, it's not going to turn in this way supposedly, but the moments going to turn in this way. So that's why that's a negative value. Where I think it totally makes sense, am I right? Since all the things is happening here, of course, your things will start to bend in towards here. Am I right? So that is the forces applications under your angular momentum. Is that clear until here? Any questions? Okay, if no question, I carry on, right? So what the these questions is challenge would be on. That's why you can see that the moment of the air must have the 82.5 newtons on that direction to make sure it's not going to fill over level. Okay, and the part B, the question asking how many weights of the horizontal pipes it can sustain or whatever. So you just need to do a reverse calculations, right? You use the same things. You just need to use a reverse calculation to make sure they are not going to bend. And bear in mind, the question given is liter per minute, or not liter per minute, it's kg per liters. I mean kg per meters. It's a kg per meter length. That's why over here you have the let me check it here. Yep, liter times your liters meters, right? How many lengths, how many weights of the liters? That's why you will have these formulas outputs. Okay, the tricky part, as I said, is the kg per meters. So when you do the reverse calculation, okay, because the second part is the required length of the horizontal section that would make the moment at point A equal to 0. That's why, since you understand this, you just need to make sure your reverse calculations, you need to consider the moment A equal to 0, and hence, from there, you do the reverse calculation for that. And your W is no longer mg for this case because it's unknown. That's why you need to start from there. When there is a negative value, you need to make a statement. That's a very good point, right? That's why in this kind of questions, I will recommend always let me know what directions you are referring to. For example, you can write anti-clockwise is a positive or clockwise is a positive. That's why these parts, you don't get frightened if your answer is different from me. Okay, because if you assume or you wish to have a different directions as positive or negative, you will have a different answers. And what I mean is different answer is different positive or negative. The answer is still the same, but you will have a positive or negative differently if you assume a different directions. Okay, and it would be good if you always let me know which one you are do the assumptions about them. Okay, so in terms of markings, it will be much easier for me to make sure that you understand the whole things. Okay, so is there any questions for this? And I would say that try the part B. And I just let you know the overall ideas, right? And if you can't get through, try yourself the part B. I would say it's interesting. Okay, even though the concept is there, you need to make the 0 as moment A, and you got the formulas anyway. So try on that and let me know if you face any difficulty. Okay. Is there any questions? Further questions for this? Yeah.
For the question, right, how to change the W?
How to change the W? You mean for this?
Yeah, that one.
Yep, that's why I leave it to you. You need to be smart to know what dice means by this. What is the length times the W contributes for that? So I leave that part to you to think of that. Okay, I leave that part to you. But I would say once you start on that, it should be easily, you can know that. Okay, because your length R1s might be no longer 0.5. That's why you will have the, just a hint, you have the L over 2. Do you get what I mean? Just a hint for this. In this case, you know that the force acts in the middle of 1 meter. So you know your R1 is 0.5. But in case the question asks you, what is the required length of this horizontal section? This total L can be any sections, any length. It might be more than 1 or is less than 1 or whatever. That's why the question introduced L over 2 for the R. And when you talk about the big W, I leave it to you for that. Okay? And I'm come back to you next class. I wish you have some thinkings on that, what's happening. Okay? So when it comes to these questions, perhaps spend 5 minutes to get the overall concept. How many of you have gone through these questions? Question 6, example 6.9. Have you gone through it? If no one, I assume none of you have tried. But anyway, don't worry. Take 5 minutes to try that. Okay, and I would suggest, right, you really need to, because what in the lecture notes, in fact, is only the theory, am I right? When it comes to the application, of course, you are going to face some challenge or face some difficulty. How you are going to use all these things, what you have learned, in fact, already included that. But there's another challenge when you want to bring into the application. You need to understand against the keywords, understand what is going on in the system. Then only you able to use all the formula we learned. Am I right? So please try the questions and you will see a lot of beauty things from there. Okay, so please take 5 minutes for this. And just to share with you, okay, just a hint for this Springle. These guys Springles, they call it. Anyway, you have Springles. So they're going to turn. Your momentums, just like these tables, the momentums of this going to contribute for the turning. And this turning will contribute to your shaft. And this shaft will contribute to the energy generations. And this is a linkage for this system. And how to start? So because at the end, you need to estimate the electric power produced. So the question starts from water in total, split into 4 springles, contribute to your rotations. This rotation contributes to your shaft rotation, and this shaft contributes to your electric power generations. So get this concept ready, drive your work plans, and then you should be able to get what you want. Okay, just try on this. Thank you. Don't worry, right? Just try first. Anyway, I'm going to explain to you. Once you understand, you should be able to do it. But don't rush it. My keywords is step by steps to see how far you can reach. And then you know which part you are stuck. Okay? I would say that when do this kind of questions, it's very important to clear your mind. Don't let for any unnecessary things trigger you. You just need to slowly, as I explained to you, understand what is this rotational contribute first. Then the first part comes to the second part and comes to the last part. And I believe for the first part should be easier because you already know well what is the momentum, not the momentum, what is the mass flow rate. So in this case, of course, you need to find what is your velocity, am I right? Because you need to know what is your MV. Just have a try, okay? I'm coming back in another 3 minutes. I don't expect, to be honest, right? I don't expect you all get the answer right now. But what I wish is you try the whole things, you know which direction you are going. That's why you can see from the questions, you are given 20 liters per second, and you should know that this is your, what is this value? 20 liters per second. Anyone tell me what is this value?
Volume flow rate.
Yep, this given is a volume flow rate. So, of course, when this is volume flow rate given, the first thing you need to do is to find your mass flow rate. Am I right? Once you're able to find the mass flow rate, you should be able to find each of these outlets, what is their velocity. How to find that? Use some creativity to understand the things. Okay, I'm going to show you later, so no worries. So once you're able to find this, and at the end, you should be able to contribute to this shaft rotational. Okay, try first. I will come back in 6:15. Then we will go through the questions and answers together. Okay. Are you all trying in class?
Yes.
Yep. Okay, good. So you can read from these solutions. A 4-arm spring gauge is used to generate electric power, right? Okay, so I think for the first part, you should able to understand. Perhaps the tricky part and the challenge part would be how we are going to link all these shaft to your momentums. Okay, so no worry on that. I'm going to show you later. Okay, perhaps I will go through the questions together first, and you can try again at home. Okay? Oh. So let's start from here. You know that, as I mentioned just now, in all this system, maybe I copy again, so you can bring. Oops. Okay, you can hear me? Okay, good. So you know that I got one input and I got 4 outputs. Due to your conservations of mass, as what we learned in the chapter 3 part 1, right? You already know that each of these outputs would be m total divided by 4. Am I right? So because it's one input, 4 outputs. So you know that each of these nozzle, we call this is a nozzle, you have an m total divided by 4. In that sense, your volume flow rate for each of these will be divided by 4 from the total as well. For this part, can you understand? Hi,
Yes.
class. Yep. So you know that your inlets, and why they use this? Because it's a volume flow rate, right? So you will have the 5 liter per second divided by your cross-sectional area of your diameters. And the diameter is given is diameter of each jet is 1 cm. So from there, you can use the V equal to VA formulas. So you're able to know that the velocity from here is 63.66 meter per second. Okay, so are you okay until here?
Yes, okay, sir.
Okay, good. So after that, you also know that the springer going to rotate as 300 RPM. So that means this whole thing, with this additional evidence, the whole thing going to rotate 300 revolution per minute. Okay, so, and of course this comes with all the things, right? So you know that I can get the omega from there by using 2 pi n. So you know that the omega, the rotational for this things, is 31.42 radian per second. Can you understand here? From the questions, Springer rotates 300 RPM, and I know that they are going to rotate 31.42 radians. And bear in mind, okay, all these things is your assumptions of the directions. And there might be have a possibility you have a wrong assumptions. That's why you have a negative value, etc. But whatever you assign, you just take it, because at the end, you are going to have all the, at the end, you are going to have the minus or positive to represent whether the direction is right or wrong. Okay, so once you get the omega, you know that my omega times my r is your velocity. Okay, and where these 0.6 come from? The center of each nozzle is 0.6. So you know that this omega times your distance is equal, right? Here, here, and here should be equal. Is 18.85 meter per second. Sorry. Yep, meter per second. And forget about the V, right? This is there might be a mistake for that. Okay, so average velocity 18.85 meter per second. Until here is okay. Is that okay, class?
Sir,
Yes.
Yep.
can I ask where is the nozzle? The nozzle is the...
The nozzle is this one. This is the nozzle.
Sir, then what about the jet?
The jet is go directions for this. So what in fact they tell you here is, that's why when you look at further on this, because you will have two different, because you got rotation and the same times you got this push forwards. Okay, that's why the total jets will have the V jet minus V nozzle, because when you push forwards, it will rotate backwards. Do you get what I mean? Let's say imagine all this water discharge from here. When they discharge here, you will contribute to your whole thing rotate backwards. Am I right? Yes, class? I mean, logical thinking for this. When you discharge here, your whole things will contribute for this rotational. Am I right? And this backwards velocity, that's why you need to negative. And the absolute for the jet is 44.81 meter per second, which is your average for the conditions. Can you get what I mean?
Yes, can understand.
Yeah, okay. So once you get that, the questions is one used to know what is your T shaft, because you are going to contribute all this rotational for the T shaft, right? Even though there's a backward thing. That's why you will have your RMV for the T shaft. That's why when you use RMV, you use the average or absolute of the total velocity for the system. And you will get 537 newtons meter. And of course, if you don't want to use this, you can use this individually forces from, because what you have right here is the average for the whole system. If you don't like that, in fact, you can use individually of this. The nozzle, of course, you need to divide by 4. That's why you will have a 4 RMV for this case. Can you get me? Okay, so once you get this, This is where this come from is from the formulas. So as I explained to you, this is very important. Am I right? Oops, this is the one. IMV, yeah. This formula is very important when you link with the rotational angular momentum with your shaft and the power. So once you get this RMV total, right? Total with the average of the jets, you know my shaft contribute that much of torque energy. So from here, you can further on to use to find your energy generations. So you solve the question. Is that okay? And where's the last part? And last part is if they're asking another condition, what is your rotational per minute? And I believe if you're unable to reach here, you can change a lot of different conditions. That shouldn't be difficult. So is that okay? Or maybe in this way, okay? So this is the process for that. Please go and try at home again. And if any questions, come back to me next class. Okay, so I think that's all. You learned the whole chapter for chapter 4. Yep, T shaft on energy. Okay, so try this question, and I'm going to share you more questions later on. Five liter per second is not 20 liter. Yep, because it's given 20. Am I right? It's given 20 liter per second. That's why you're going to divide by 4. That's why each of these is going to contribute 5 liter per second. Okay, because this one is already the nozzle part. It's already divided. So please take care for that. And sorry, T shaft equal to 4R. You mean for this part? You mean for this part?
Yes, sir.
Yep. No, this formula, this one is not show you. This give you a choice. Either you use this or you use this, but this is not given. Okay. In fact, if you want to use this, you need to consider the M nozzle, but not the M total. That's why I need to times 4, because each of these contribute to your total. Can you get me?
Yeah.
Yep. Why is the V jet total is minus a bit lost? You mean for here? Because as I said, in order to get the resultant or to get the net velocity, whatever you push in front, that will be generated backwards. So you need to know what is the net velocity for these conditions. That's why you need to use a minus. Which one is the biggest? Because this contributes for you velocity over here. In the same time, they also contribute backwards. You need to get the net velocity happening in this system. Then you start the calculation. Okay, did I answer your questions, Chen Jin? But anyway, try on that first. Try on that again. And any questions, we'll come back again in next class. Okay, yep. So I think that's all you need to know for this chapter 4. And that's why the tricky part again, as I said, is not about the formulas, because the formula is straightforward, it's just simple. But the key thing is how well you understand the system. And again, all these things you need you need to try the questions, and there's no shortcuts available. Okay, so I think that's all for today. Any questions you want to ask? Any questions, class? Okay, I hope you understand what's going on, and please try the questions, chapter 4. Okay, and I will post the answers later, and I will say most of the answer is already here, but please don't refer to the answer and redo one more times, so you should able to get a very good understanding for this. Okay, and next class I'm going to show you some examples as well. Okay, the keywords is make sure you're familiar with all these fundamentals first, because if you understand, so the keywords, don't memorize the thing, because you just purely memorize the things, or you memorize the answers, the question, it doesn't help you, because different cases you need to understand the concept behind this application, and then you can apply accordingly or appropriate formulas for that. Then eventually you will get the answer you want. Okay, I think I will stop here. Any question you want to ask before I dismiss you all?